Hello students, this is Hamza Noor and today we have a question from M1 May June 2019 paper 42 question number 4 and the topic is work energy and power. Let's see what this question says. A constant resistance to motion of magnitude 350 Newton acts on a car of mass 1250 kg. The engine of the car exerts a constant driving force of 1200 Newton. The car travels along a road inclined at an angle of theta to the horizontal where sine theta is equal to 0.05. So an exact value of sine theta is given, so you would be using this value. Find the speed of the car when it has moved 100 meter from the rest in each of the following cases: when the car is moving up the hill and the car is moving down the hill. So first I'm considering the motion of the car when the car is going up the hill. So let's make the diagram. The hill is inclined at an angle of theta where sine theta is equal to 0.05 and length of this hill is 100 meter, because you need to find the speed of the car when it has moved 100 meter from the rest and when the car is moving up the hill. So this is 100 meter. Let's say the car is over here, it is going from bottom to the top. Okay, and this vertical height is 100 sine theta, where sine theta is equal to 0.05. So what do you need to find? You need to find the speed. So we are going to make a work energy relation from the bottom of the hill to the top of the hill. Okay, so we have external forces obviously, because there is a resistance of 350 newton and a driving force of 1200 newton. So our basic work energy relation is that mechanical energy at start of the journey plus work done positive minus work done negative, and this whole thing is equal to mechanical energy at the end, where mechanical energy is the total of kinetic energy plus the potential energy. All right, this is the basic equation which you need to remember. And if there are no external forces, so mechanical energy at the start is equal to mechanical energy at the end. So this means that kinetic energy at start plus potential energy at start plus work done positively minus work done negatively, and this whole thing is supposed to be equal to kinetic energy at its end plus potential energy at end. Okay, so the since the question is saying that the car is starting from the rest, so initial speed is equal to 0, so kinetic energy at the start of the journey is also equal to 0. Since the car is at the bottom initially, it is going up the hill, so potential energy at the start is also equal to 0. All right, work done positively. What we know is that the driving force is having a magnitude of 1200 newtons, and when the car is going up the hill, it will be covering a distance of 100 meters. So 1200 multiplied by 100 will be the work done positive, minus the resistance force is 350 newton, and work done by the resistance would be, I mean work done by the force which is hindering the move. This is called work done against the resistance. So 350 multiplied by 100. All right, and this whole thing is equal to kinetic energy at end plus potential energy at end. Kinetic energy at the top of the hill would be half mv square, where m is 1250 and we don't know. We need to find the speed. We need to find the speed of the car when it has moved 100 meter up the hill. So 1250 divided by 2 multiplied by v square, and potential energy at the top of the hill would be mgh. So the mass is 1250, g is 10, and height we have to take 100 sine theta, and sine theta value is 0.05. So 100 multiplied by 0.05, this is 5. Okay, the height is 5 meters. So just simplify this, you'll get your answer. 1200 multiplied by 100, this is 120,000 120,000 minus 35,000 is equal to 1250 divided by 2 is 625. 625 v square plus 1250 multiplied by 10 multiplied by 5. This is 62,500. So you need to find the value of v, as simple as that. So making v square the subject, 120,000 minus 35,000 and minus 62,500. This is giving you 22,500 divided by 625. V square is equal to 36. V square is equal to 36. So V is equal to 6 meters per second. This is the speed of the car when it has moved up the hill. Now we'll be considering the second work energy relation when the car is moving down the hill. We'll make the diagram on the next page. Same information given. This is 100 sine theta, which is 5 meter. This hill is having a length of 100 meter, and the car is coming from top towards the bottom. So considering the work energy relationship over here, same thing, kinetic energy at start of the journey plus potential energy at start, because we are starting from the top, okay, plus work done positively minus work done negatively is equal to kinetic energy at end plus potential energy at end. All right, so kinetic energy at start, since in both of the cases the car is starting from rest, so initial speed is 0, so kinetic energy at start is 0. But wait, potential energy at start would be something, because the car is starting from the top of the hill. So mgh is the potential energy at start. The mass is 1250, g is 10, and height is 5 meters. 100 sine theta plus work done positively. We have the same magnitudes of the driving force, 1200 Newton. So work done positively is 1200 multiplied by 100, because 100 is the distance to be covered, minus work done negatively. 350 Newton is the resistance and 100 is the distance. So 350 multiplied by 100. This is equal to kinetic energy at end. So, and I mean equal to kinetic energy at end plus potential energy at end. So kinetic energy at end half mv square, and here we need to find the speed basically, so v will be unknown. So half into 1250 times v square, and then plus the potential energy at the bottom of the hill at the end of the journey would be 0, because the car is now at the level of the ground. All right, so as simple as that, find the value of v. 1250 times 10 times 5, this is 62,500 plus 120,000 minus 300 and, oh sorry, 35,000, and this is equal to 625 v square. So 62,500 plus 120,000 minus 35,000 divided by 625. V square is equal to 236. Okay, and under root of 236 is 2 root 59, which is 15.36. Correct to three significant figures. V is equal to 15.4 meter per second. All right, easy question. Most probably I'll be making more videos in this week, because you have M1 exam on 22nd of October 2020 if I get some free time, and I'll be making more videos. And until next time, thanks for watching.